Okay, so we're going to have a look at another question from the 2022 HSC Standard 2 Maths paper. This is question 28. Question 28. So we're told a dam is in the shape of a triangular prism which is 50 meters long as shown. Both ends of the dam, A, B, C and D, E, F, are isosceles triangles with equal sides of length 25 meters. The included angles BAC and EDF are 150 degrees. Calculate the number of litres of water the dam will hold when full. Okay, so first we want to calculate the volume of this shape in meters cubed. Then we want to convert that to litres using our known meter cubed to litre conversion. So this is a prism. Because this is a prism, if we can calculate the surface area of the triangle on the front, multiply it by the length of the prism, this will give us the volume. So we have a triangle that looks like this, triangle that looks like so. This is 25, this is 25, this is 150 degrees. Now there's a few different ways to do this. We could use sine area formula here. So the area of this shape is going to be 1/2 times A times B times sine of the angle between A and B. A and B are both 25. This is A, this is B, this is capital C. So the area is 1/2 times 25 squared times sine of 150. So therefore the area of one of these triangles, and if we get a long number we'll round this. 0.5 times 25 squared times sine of 150 is 156.25. 156.25. This is in meters squared. So because this is a prism that looks something like this, we can just multiply that area by the prism's length and this will give us the volume. So we know that volume is going to be area times 50. Area is 156.25. So we've got to multiply that by 50. So therefore the volume will be 156.25 times 50, which is 7,812.50. 7,812.50. And this is meters cubed. Now that we have the volume, they've told us to calculate the number of litres. Well, we have a conversion from meters cubed to litres, a definition. 1 metre cubed is definitionally 1,000 litres. So we're going to be using this to convert the meters cubed we've just found into litres, which is what we want. So we're going to multiply this by 1,000. So volume times 1,000 is 7812.50 times 1,000. So this is the capacity. So therefore the capacity is 7812500. And this is in litres. And this is an exact answer because it was a whole number. When we calculated the area of the triangle, it gave us 2 decimal places. The volume, 1 decimal place, multiplying this by 1,000, this gives us an exact number of litres. And this is the answer. In terms of the marking, you get 1 mark for attempting to find the area of one of these triangles or some equivalent merit. So if you start to use the area sine rule, or you cut the triangle in half and try and use trigonometry to find a height or a length or something like that, that will get you a mark. Finding the base length of the triangle or some equivalent merit will get you another mark. So sort of good working at the start to try and find something. If you want the 3rd mark, you'll need to get the volume of the dam in meters cubed or equivalent merit. So you may not have the volume, but you may have some other combination of useful information that's getting you close to the answer. It's possible to get 3 marks. For the 4th mark, you need the capacity in litres, and you need this exact solution in this case. So this is how we do question 28 from this paper.